Okay, so in this video we're going to be solving polynomial equations. Now of course you remember that solving is just another way of saying finding the zeros or the x-intercepts of a polynomial equation, if you were to plot it. Okay, so there are basically speaking, there are two methods to use. So I'm going to present two different examples, each explaining those methods. The first one is a more common method, and the second one is probably easier if you get lucky. So let's see these two examples. So the first one we've got is x cubed minus 4x squared plus x plus 6 equals 0. Now, of course, the first thing we're going to do is we're going to use the factor theorem to try and find out one of our factors. Then we're going to use long division to find our other factor. Okay, so here we go. So first, we're going to try different values. So this is our polynomial with respect to x here. Okay, so I'm going to try different values for x until I get one that gives this polynomial equaling to 0. And that will be a factor. That's what our factor theorem has said. So let's try putting in the value 1 here. So x 1 cubed is 1 minus 4 plus 1 plus 6 gives us equals 6, 7, 8 minus 4, which gives us plus 4, which is not 0, so that's no good. Let's try another one. Let's try 2. So 2 cubed is 8. 4 times 2 squared, that's 4 times 4, which is 16, plus 2 plus 6. 8 minus 16, that's minus 8, plus 2, that's minus 6, plus 6. That does equal 0, which is very good. That's a tick. Very good. So we're going to divide this by x minus 2, because 2 is what we had here, and that is our factor theorem working for us there. So let's write it down properly. We've got x cubed minus 4x squared plus x plus 6, and going to divide that by x minus 2. So how many x minus 2's are there in x cubed? Well, we've got at least x squared of them. So x squared multiplied by x minus 2 gives x cubed, x squared minus 2x squared. Now, subtracting the top from the bottom gives x cubed, that gives 0. Minus 4x squared, take away negative 2x squared is negative 2x squared. Let's drop the next term down, plus x. How many x minus 2's are there in minus 2x squared plus x? Well, that would be minus 2x. Multiply this term by this over here, expression over there. It's minus 2x squared plus 4x. Subtracting the bottom from the top gives us 0. X take away 4x is minus 3x. Drop this bottom one down, plus 6. Now, once again, how many x minus 2's are there in minus 3x plus 6? That's minus 3. Okay, minus 3 times x, minus 3x, minus 3 times minus 2, plus 6. Subtract again. Remainder is 0, which is good. That's what this remainder theorem had told us. So far we have factorized our way down to this. Here's our initial equation, our initial 4x squared plus x plus 6 equals 0 is our initial equation, and we've factorized it this far to say, well, it's x minus 2 multiplied by x squared minus 2x minus 3. So now all we've got to do is change this from a quadratic and get that into factorized form. So here we can use the thinking about it method, and we notice that two factors that multiply to give minus 3, well, let's do it properly and list all the ones we can think of. We've got 1 and minus 3, we've got minus 1, positive 3, and that's all we've got. So now we've got to choose which one of these adds together to give minus 2. So obviously this top one here. So we can factorize this bit to x plus 1, x minus 3, and we've still got that first bit, x minus 2, and of course these both will have to equal 0. Now we can use the null factor law to say that this one has to either equal 0, or that equals 0, or that equals 0. So I've got x must be 2 from the first one, or x equals minus 1 from this middle one, or x equals 3 from this last one here. And there we go, we're fully done, we've fully solved it, we've found the solutions. X could equal 2, minus 1, or 3. So those will be your x-intercepts if you're going to plot it. Okay, now there's one other solution method we can use to solve polynomial expressions. And that's if we have them in something similar to turning point form. So, before we do this, I just want to remind you that, say, 2 squared is equal to 4, but minus 2 squared is also equal to 4. However, 2 cubed is equal to 8, and minus 2 cubed is equal to minus 8. So here, if you were to take the square root of 4, your answer could be minus 2 or 2. You're not sure. So when you've got something like the just square root, you write plus or minus the square root to make it really clear your answer could be positive or negative. However, that's different with cubing. If it's a cube root you're talking about, a cube root of 8 is equal to 2, and a cube root minus 8 is equal to minus 2. So you don't need to do the plus or minus for cubing. Now if we were to continue going, we could say 2 to the power 4 is 16, minus 2 to the power 4 also is 16, and we can also do 2 to the power 5 is 32, or negative 2 to the power 5 is negative 32. So this sort of trend continues. If our index up here, or our exponent, or power, or order, if that's positive, you need to do a plus or minus. So like plus or minus that's 4, the quartic root of 16, you need to do plus or minus. But if it's an odd number as your exponent, you do not need to do it. So just thought I'd need to mention that quickly, because our next example will involve this sort of stuff. So let's solve. Let's pick at least slightly challenging one. Half 5 minus x cubed minus 32 equals 0. Okay, so what we're trying to do is isolate x. So we want our final answer to be like x equals something, and that will be our solution, whatever these somethings are. So first I'm going to add 32 to both sides. So, oh, you don't really need to do the equals when there's already an equals over there, by the way. But anyway, 5 minus x cubed equals 32. Now, here I'm multiplying by half, so I'll divide by half, or in other words, the opposite of timesing by half is timesing by 2. So I'll multiply both sides by 2. Gives 64. Now here's where I get rid of this this to the power of 3. So I'm going to do a cube root here, because 3 is an odd number, I don't need to do the plus or minus thing. Cube root of 64. Now, because I've been doing maths a lot, I know that 4 to the power 3, let's do it. 4 squared is 16, and I know that 16 times 4 is 4 cubed, which is 64. So I know that that answer there is actually 5 minus x. That is actually 4. Okay, now I'm going to add x to both sides and take away 4 from both sides. 5 take away 4, 1. So there we go. The answer for this one here is x equals 1. And there's only one solution, which means it only goes through the x-axis once. So one solution. So there you go. There are the two different ways you can solve polynomial expressions. As I mentioned earlier, this first way is the much more common way and the way you'll be using the most. So get used to it. See you later.